Okay, let's begin with implicit differentiation. So we perform the implicit differentiation if the function is implicit function. And when we say implicit function, it is the type of function like the one I have shown here, where you'll not be able to isolate the dependent variable. If you want to find y by itself in this equation, it is not possible. So those type of functions where you cannot isolate the dependent variable, they are called the implicit function. And in order to find the derivative of the implicit function, we use a special technique called implicit differentiation. Here we have the example. Suppose if you look at the graph here, this is y equal to f of x. We might think that this is y equal to f of x, where you can separate y. But no, we cannot separate y in this function. We cannot write like this. Instead, this is not correct. Instead, for the function like this one, we write f of x and y is equal to 0. So this is the implicit function. So this is the correct function for the graph which is shown here. If you think of college algebra, you might think that you draw a vertical line like this, and vertical line is crossing this graph in 1, 2, 3 different places. And you might say that it is not a function. In fact, this is not the explicit function like this one. This is not y equal to f of x. Instead, it is f of x y equal to 0. This is the implicit function. And then when you find the derivative of the implicit function at any point, you'll get the slope of the tangent line. The concept is still the same. When you find the derivative, you'll get the slope at a point on the graph. If you want to evaluate the derivative at a point, you'll get the slope of the tangent line. Now we are going to work on some example where we can find the derivative of implicit function like this using a technique called implicit differentiation. Example, use implicit differentiation to find the derivative of y with respect to x for each of the following functions here. The first one, a, we have y squared plus xy plus 1 cubed is equal to x plus 8. We have to find the derivative dy over dx. Now you can see you cannot solve this function to find y by itself. That's why this is implicit function. This is implicit function. And in order to find the derivative of implicit function, we use a technique called implicit differentiation. So we differentiate everything with respect to x because we want dy over dx. So this can be written as d over dx, the derivative with respect to x of the first term, which is y squared, derivative with respect to x of the second, which is xy plus 1 cubed, equal to derivative with respect to x of that x, and then derivative with respect to x of that 8. So we have to differentiate everything with respect to x, derivative of the first, derivative of the second term, third term, and fourth term. Now here, this one, here you have to be very, very careful. Sometimes this is very confusing. So in this step, let's see, you have to find the derivative of y squared with respect to x. So you are not finding the derivative of x. We are finding the derivative of y with respect to x. So if you see anything like this, you have to use the chain rule. Derivative of y squared, if you use the power rule, this 2 will come in front, and you reduce the power by 1, it will be 2y. Then you have to multiply by the derivative of inside function, that is derivative with respect to x of this y, because y is the function of x. If it was x, it will be dx over dx, it will cancel, and it will just be 2x. But here is y, that's why we have to multiply by dy over dx. That is very, very important concept that you need to know while differentiating using implicit differentiation. Let me finish this step using that technique again. Plus, Now in this one, derivative with respect to x of, there is an inside function and there is an outside function. Your outside function is a cubic function, inside function is xy plus 1. So here we have to use the chain rule because you have inside function and outside function. So this 3 will come in front when you use the power rule, and you reduce the power by 1. That's the derivative of outside function. Now you have to multiply by the derivative of inside function. Multiply by the derivative of the inside function, which is xy plus 1, equal to, on the other side, derivative with respect to x of x, that is 1, and the derivative of the constant, that is 0. So we use the implicit differentiation in this step along with the chain rule there. Let's continue our simplification. So in next step, I can write, let me grab my pen. 2y dy over dx is there. And then we have a plus 3 times xy plus 1 squared. And over here, we have to find the derivative with respect to x of xy plus 1. Derivative of 1 is 0, no doubt on that. That's a constant. But here we have to find the derivative of x times y. Whenever you have x times y, that's a product rule. So we are going to use the product rule there. And the product rule says first function, which is x, multiplied with the derivative of second, derivative of y with respect to x, plus the second function, which is y, multiplied with the derivative of first, derivative of x with respect to x is 1, equal to, on the other side I have 1 plus 0, which is 1. Our goal is to simplify this and find this dy over dx. We have to solve for dy over dx. Okay, now we have 2y multiplied to dy over dx plus, I am going to distribute this. So if I multiply this with that, what we get is, here is 3 times x. That will be 3x. And also I have xy plus 1 squared. Xy plus 1 squared. And also I am multiplying with that dy over dx. So dy over dx. Then if I multiply over here, it is y times 1 is y multiplied to this one. So that is 3y xy plus 1 squared is equal to 1. In next step, we are going to, from these two terms, the first term and the second term, I am going to factor out dy over dx. I'm going to factor out dy over dx. So let's factor out dy over dx. If I factor out dy over dx, from the first, 2y is remaining. And then from the second, when I factor this out, I'm left with 3x multiplied to xy plus 1 squared. 3x, let me write it correctly, 3x multiplied to xy plus 1 squared. I want to find this dy over dx, that's why I factor it out, equal to, on the right hand side I have this 1, and this term here, you can see 3y multiplied to xy plus 1 squared. This does not have dy over dx, so I'm going to move it to the other side, or I'm going to subtract it from both sides. So it will be minus 3y xy plus 1 quantity squared. So that is our second last step. So now my derivative will be dy over dx is equal to, now if I want to find dy over dx by itself, this is multiplying here. So we have to divide on both sides by that, so that on the left hand side it will get cancelled. On the right hand side it will be 1 minus 3y. You have xy plus 1 squared already there in the right hand side. You are dividing by this quantity, which is 2y plus 3x multiplied to xy plus 1 quantity squared. So that is the derivative of this implicit function given here in part A. Now let's work on part B. In part B, we have 6x cubed minus 13xy plus 7y cubed equal to 0. So this function is implicit function. Implicit function because you cannot solve this for y easily. So this is implicit function. So we perform the implicit differentiation. That means we have to differentiate each term with respect to x. So it will be d over dx of 6x cubed minus d over dx of 13xy plus d over dx, that is derivative with respect to x, of 7y cubed equal to d over dx of 0. Then let's see what we get. The first one is derivative with respect to x, so I don't have to worry about anything. I can just use the power rule. So if we bring that 3 down, 3 times 6 will be 18, and reduce the power by 1. Then minus, see, it's a constant multiple rule. 13 is a constant. It is multiplying to that function x times y. So I can take that 13 out. After I take the 13 out, inside the parenthesis, I have x times y. I have to find the derivative of x times y. X times y, that is the product. So we use the product rule. Product rule says first function, which is x, multiply to the derivative of second. Second function is y. So derivative of y with respect to x, plus the second function, which is y, multiply to the derivative of first. Derivative of x with respect to x is 1. Then plus, now over here, we have to differentiate 7y cubed, but it is with respect to x. So if you use the chain rule and power rule, this 3 will come down. So 3 times 7, 21. Reduce the power by 1, y squared. Because we are differentiating y with respect to x, we have to multiply here by dy over dx equal to, this is a constant, derivative of constant is 0. So derivative of 0 is 0. Okay, let's continue the simplification. We have 18x squared. Now if I distribute this 13, it will be 13x times dy over dx. So minus 13x times dy over dx, because I'm distributing that 13 here. And also here, it will be negative, because negative multiplied to positive, negative. 13 times y times 1 is 13y. Then plus, after that, I have 21y squared times dy over dx equal to 0. I am looking for dy over dx, so I'm going to keep these two terms, this one as dy over dx, this one as dy over dx. I'm going to keep these two on the left-hand side, and then I'm going to move the other terms to the right-hand side. So this is what I'm doing. On the left-hand side, I have this term, let me write that, 21y squared times dy over dx. And the other one is here with dy over dx, that is minus 13x dy over dx. So the terms with dy over dx, I am going to keep that on left-hand side because I'm looking for dy over dx. And then I'm going to move everything else to the right-hand side. So this 13y, if I move it to the other side, it will be positive 13y because I'm adding 13y on both sides. And if I move this to the other side, it will be negative 18x squared because I'm subtracting 18x squared on both sides. I am looking for dy over dx. So in these two, dy over dx is a common factor. So let's take that out. Dy over dx out. If I factor that out, here I have 21y squared minus, if I take dy over dx out from here, negative 13x equal to, on the right hand side, I have 13y minus 18x squared. So if you divide on both sides by 21y squared minus 13x, then dy over dx, the derivative is equal to 13y minus 18x squared. We are dividing that by 21y squared minus 13x. So that is the derivative of the implicit function given here in part B. Example, find an equation of the line which is tangent to the curve x multiplied to cube root of y plus y minus 10 equal to 0 at the point 1, 8 on it. So point is already given. We are asked to find the equation of tangent line. In order to find the equation, we need the point and the slope. Point is already there. So next thing we want is the slope. And the slope is the derivative at this point. So let's first find the derivative. So here, the equation is this one, which is x multiplied to y cubed, cube root of y. Cube root of y is same as y raised to 1/3, that is the meaning of the cube root, plus y minus 10 equal to 0. This equation you cannot solve for y easily, so this is the implicit function. So we are going to do the implicit differentiation. So your implicit differentiation will be d over dx, derivative with respect to x of the first term is that, plus derivative with respect to x of the second term, minus derivative with respect to x of the third term, equal to derivative with respect to x of that fourth term. That is the implicit differentiation. Now, if you look at the first term carefully, this is the derivative of the product, x multiplied to y to the 1/3, that is the product. So we use the product rule here, which is first function x multiplied to the derivative with respect to x of the second, let me write like that, plus second function y to the 1/3 multiplied to the derivative of the first, derivative of x with respect to x is 1. Then plus the second term, derivative of y with respect to x, I don't know what is that, it is dy over dx, that's what I'm looking for. Then derivative of this constant is 0, and the derivative of 0 is 0, that means we have equal to 0. Okay, this one is good, this one looks good. Here we have to find the derivative of this one, y raised to 1/3 with respect to x. We are differentiating a y with respect to x. It has a power, so first we are going to use the power rule. Let's do that. X, if you use the power rule, you bring the power in front, so 1/3 in front, and then reduce the power by 1. 1/3 minus 1 is negative 2/3. And also, you are differentiating y with respect to x. When you differentiate y with respect to x, we have to multiply by dy over dx at the end. You know this. Then plus, here we have y to the 1/3 multiplied to 1, which is y to the 1/3. And then plus, we have dy over dx equal to 0. Now, let me simplify one more step here. Here I have x multiplied to 1, that is x. In the denominator, there is a 3. And then here I have y raised to negative 2 over 3. Y raised to negative 3 over, y raised to negative 2 over 3. If I move it to the denominator, it will be y raised to positive 2 over 3. If you use the law of indices, if you take it to the denominator, the power will have opposite sign. And this is multiplied to dy over dx. Then plus I have y to the 1/3 plus dy over dx equal to 0. And make sure you know what we are doing. We want to find the slope. Slope is dy over dx, okay, dy over dx when x is 1 and y is 8. So we are going to plug in x equal to 1 and y equal to 8. So let's do that. At 1, 8, if you plug in the value, so here, if I plug in 1 for x, that is 1, over, you have a 3, Then if you plug in 8 here, everybody look at the screen carefully. If you plug in 8, this 8 for y, you have 8 raised to 2/3. So 1/3 is the cube root. Cube root of 8 is 2. And then you are squaring it. So 2 squared, that will be 4. And then you have this dy over dx. And then you have a plus. And this one, y to the 1/3, that is cube root of y. Y is 8. So cube root of 8 is 2 plus dy over dx equal to 0. Now you can see, let's keep everything with dy over dx on the left-hand side. You can see dy over dx here and here. So the first one is 1 over 12, because 3 times 4 is 12. Then you have dy over dx. Then plus you have dy over dx there. And if you subtract 2 on both sides, or if you move this 2 to the other side, -2, because I want to find dy over dx. So factor that dy over dx out. You get 1 over 12 plus 1 equal to -2. And then dy over dx multiply to 1 over 12 plus 1, that is 13 over 12 equal to -2. Then if you want to find dy over dx, that is equal to -2 is there. You are multiplying here by 13 over 12. So if you divide on both sides by 13 over 12, it is same as multiplying by 12 over 13. That is equal to -24 over 13. So that is the slope. Okay, that is the derivative at 1, 8, or that is the slope of the tangent line. Now the equation of the tangent line. So what we know is the equation will be, we have the formula for the equation, that's y minus y1 equal to m times x minus x1. So y minus, your y1 is 8. Your slope is -24 over 13. Then you have x minus, x1 is 1. So we get y minus 8 equal to, if I multiply here, -24 over 13 times x, -24 over 13. Negative and negative will be positive. 24 over 13 again. Then we get y equal to, this is -24 over 13x, because I'm multiplying with x. So -24 over 13x. Then we have plus 24 over 13. And if I move over 8, it will be plus 8. So y equal to -24 over 13x. Now we have to add these two, 24 over 13 plus 8. So yeah, it will be 128 over 13. So this is the equation of the tangent line for this implicit function given here. Now what we are asked to do is, after we find the equation of the tangent line, we are asked to sketch the curve and the tangent line. So we need to draw the curve and also the tangent line. What I'm going to do is, I'm going to sketch the curve and the tangent line using a different program called GeoGebra. So here is my function, which is x multiplied to y raised to 1/3, or that is the cube root of y, plus y minus 10 equal to 0. That is the function. And this is the graph of the function. This one here, and the section that you see here, that is the graph of the function. And then this is my equation. We got y equal to -24 over 13x plus 128 over 13. And this is the tangent. So we have the tangent at the point 1, 8. So this point here, where there is a tangency, is 1, 8. Okay, if I make it big, you can see we have the tangent at 1, 8 right here. And the equation of the tangent is -24 over 13x plus 128 over 13. So you can see here, when you go from left to right, the tangent line is going down, meaning of that is it has a negative slope, which is -24 over 13. And this one here, you can see we have 128 over 13. If it was 130, it will be 10. So the y-intercept is little below 10. If we zoom in, you can see the y-intercept is little below 10. Okay, so that is the equation of the tangent line for the implicit function that was given in the problem. So when we sketch the graph, we just sketch the function and the graph together on the same grid.